The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
So, Paul, I heard that you were in Denver a couple weeks ago.
Yeah,
Did
last week, actually.
Oh, it was last week. Okay.
Yeah.
Well, did you eat any good food while you were in Denver?
Well, being in Denver and being landlocked, there was one good meal I had, and it was a Mexican place, and it was kind of like this ceviche type of thing. It was like round, I don't know, maybe a 5-inch diameter cake that they made with ceviche, all compressed. It had shrimp and it had scallops and all kinds of seafood in there, and it had that citrus thing like the ceviche, and it had some raw fish. So some of the fish was raw, some of the fish was cooked. It was actually really good. One of the train guys I was with for a meeting suggested it, and we went there, and he recommended that, and it was quite delicious, which I found odd, being in Denver, which are like 6 million miles from the nearest ocean.
Right.
But I guess they can fly that stuff in anywhere in the world, fresh, I guess. Let's see, I also went to I had a new experience. There was a place I've never heard of. They don't have them up here, but it's called Mod Pizza.
Yeah.
It's kind of like a Chipotle, but you walk in, you order your pizza, you order whatever toppings you want. So, like if you go to Chipotle or Moe's and you get the burrito, you pick your toppings and everything else. Like Subway, you pick what's going in your sandwich. This was a pizza, and you pick your toppings, and they throw it in the oven for like 10 minutes. It comes out like, a 10 or 12-inch pizza, just enough for enough for a normal person. But the best thing was, at the end, they have these mod cakes, which is like a big ding-dong or a ring-ding. So up here, they have ring-dings and ding-dongs. But when I was talking to Brent, my boss, he never heard of ring-dings. So it looks like a hockey puck, chocolate cake.
Yes. Chocolate with the cream in the middle.
Yeah. That was really good. I also went to a Vietnamese place, and I had pho.
What do you have?
Oh, I'm sorry. I got pho. It's pho. Because,
yes, I don't
want to hear from Katie Forbes. She'll come and kick my butt, and she'll be hauling pho cubes at me. So I don't want to go down that road again. But that was wicked good. I had I ordered an appetizer in the bowl of pho. And we talked about that before. It's got the meat in there. They kind of give it to you like raw.
I asked, what kind of meat did you get?
Brisket.
Do you remember?
Brisket.
Yeah. Okay.
It was brisket, and then
good.
they put fresh basil and some lime and some I forget what else on the plate beside it. You put in what you want. You can put in sriracha in there. And I ordered an appetizer. I ordered these spring rolls, these vegetable and shrimp spring rolls. And I figured, okay, I'll just have a couple. I thought they would be small. They were huge. they were about 8 inches long and about 1.5 inches thick. And there was 2 of them, and I couldn't finish them. And of course, you're in a hotel. And, what are you going to do? Take it back and have it? So
I know.
I actually did take it back to the hotel and left it in the fridge. So that was it. I mean, overall, I didn't have anything dazzling. It was just good. But, that was only my second time in Denver, and I find the food average. But I probably didn't eat at really good places. I know one thing I didn't have, and I wouldn't try. It was Rocky Mountain oysters, and we'll just leave it at that.
Yeah, I can't do. No.
We'll just leave it at that.
Well, being in Denver, did you notice any altitude change when you were there?
No, I mean, I was surprised. The first time I went to Denver, I was surprised how flat it is. I was thinking it's near the mountains. I mean, obviously you can see the Rockies, and they're like, I don't know, somebody told me they're like 40 or 50 miles away. They look closer. But you're right there where the Rockies meet the plains. Flying in, all you see is the plains. It looks just like Kansas, which is the next state.
Yeah.
East Kansas.
Then you got to walk 10 miles to get out of the airport.
Yeah, you really do. Yeah, no, but I didn't notice any change, in the altitude, but it was good.
Okay.
I mean, I like that. Next time I'll probably find some local cuisine. All right.
Next time you're in Atlanta at the office, there's a place down there called Saigon Cafe. They got pretty good pho.
Yeah, I like pho. All right, so Katie, thanks for teaching us. If she's listening, I doubt she listens. She's too smart. But thanks for teaching us the right way to pronounce that so we don't get in trouble. All right. Anyway, welcome everybody to the METUS Tech Show. My name is Paul Shavs. Joining me remotely is Scott. Scott, say hi.
Hey, guys.
And once again, for part 3, Austin Blume. Austin, how you doing? Welcome.
Doing great. How about you guys?
Yeah, living the dream.
Doing good.
So what are we going to talk about today?
I think M&P calls.
Yeah, we're going to
residential.
This would be a good one.
We did 2 weeks of City Multi calls, Common TSA calls. Pretty long episodes. Most of our episodes go, 30 to 40 minutes, and I think the last 2 were an hour each. So we probably had a lot of people with driving with their eyes glassed over and so on. Who knows? But Austin, was there something you wanted to follow up on the last call? You wanted to follow up something from last week, or am I imagining things?
You might be imagining things.
Okay, which happens. I'll have to edit this part out so I don't look like a fool. That's the beauty of our show. We edit things out because we say stupid things, so nobody knows we're stupid.
Paul, why did you just give them the secret?
I'm just honest like that. Okay, so let's talk about common M&P faults. So, Austin, you're a TSA, Technical Service Advisor, for those who didn't listen to the last 2 shows, and you field calls from technicians and you offer tech support. In the last 2 shows, people can go back and listen to, I would say, the most common or some interesting calls that you got regarding City Multi. So let's switch gears, talk about the residential light commercial equipment, the M&P series equipment. What's the first call you want to go over?
I think communication faults would be the most prevalent call that we get. So most communication faults are going to be on startup, typically because wiring issues or electricians made a mistake, something like that. But they're pretty easy to figure out.
All right, so we have 3 wires. Let's just review for those who don't know, because there could be somebody listening who's never worked on an M&P series piece of equipment. Yep. So from the outdoor unit to the indoor unit, a 1-to-1 system, we have 3 wires. They're labeled S1, S2, and S3 outside, and they're labeled S1, S2, and S3 inside. So one thing that can cause, this is the easy one for me, one thing that can cause communication is that the S2 and S3 are reversed, or S1 and S2 are reversed. But they're polarity sensitive. So S1 has to go to S1, S2 to S2, S3 to S3. And the important thing to remember here is we have wires carrying voltage, which is we're all used to, but they're also communicating. So they're also sending, besides voltage, 1s and 0s. So that's the communication we're talking about. And that has to happen for the outdoor unit, has to see that indoor unit, has to talk to it, and it has to hear back from it. And if we don't have that, that's a communication fault. So
yes. So essentially, the outdoor unit between S1 and S2 produces 208, 230 that delivers power to the indoor unit and powers it up. Between S2 and S3, with no wires connected to the outdoor unit, it's a solid 26 volts DC. So essentially, if you had no wires on it, if you wanted to check if the outdoor board was providing the proper voltage, then we should have a solid 26 volts DC. Yeah. Now, as soon as you hook up wires to the outdoor unit, so you've got all 3 wires outside and inside, you start getting a bouncing DC voltage. And that typically is going to be 10 to 24 volts, 12 to 24 volts is what the book says. But it's a bouncing DC voltage. If you ever were to not have a bouncing DC voltage, then you're probably going to have a communication error. Right. And that can be discovered a few different ways. So
that's a good thing. So we start off out the outdoor unit, right? If with the wires connected, the indoor unit connected, I should have 208, 230 between S1 and S2. And between S2 and S3, I should have a bouncing 24 volts DC, roughly.
Correct.
Right. So communication.
And
it's going to appear different on different meters. So having a true RMS meter, we've talked about that before. So a good test, if I'm getting on S2 and S3, nothing. A good test is to power it off, disconnect S1, S2, and S3 at the outdoor unit, and go back and measure S2 and S3. If I get nothing, what does that mean, Austin?
Well, that's essentially saying that your outdoor control board is not producing the voltage that you need. So you got to step it back into the outdoor unit and start looking at, like we talked on the last podcast, it's power in and power out on all these boards. So do you have the voltage coming into the board, the high voltage DC on the control board, typically around 300 volts DC, to step it down to that 26 volts DC needed to output?
All right. And if I measure there and I do have a solid 24 volts, then that means that outdoor unit is doing its job. So
correct. Yep.
So now I'm looking at the indoor unit. So I'm going to go power it. I'm going to go power it back down, connect S1, S2, S3. Now I'm going to go to the indoor unit, and I can.
Well, basically, there's 3 different voltages you might see at the outdoor unit. So you walk up to it, all the wires are connected. You're either going to get a solid 26 volts DC. All right. Now, the indoor unit's required to make that DC voltage bounce. So if you're outside and you got a solid 26 volts DC, then it's leaving the outdoor unit, but is it actually making it to the indoor unit? So that's where you would step inside and say, hey, do I have 26 volts DC inside? And if you do, more than likely something to do with the indoor control board. Typically, right? It really depends. Does the indoor unit light up and things like that? If it doesn't light up, it may be something more serious, like a fan motor took out a power board or something like that. But if it lights up, it comes on, it's giving you error codes, but you just have a solid 26 volts DC at the indoor unit, then it's probably just a bad control board. The other possibility is you walk up to the outdoor unit and you have no voltage, 0 volts on the outdoor unit across S2 and S3. That one is very, very common. Like we talk about in the City Multi podcast, when you have a grounded communication wire with low voltage DC, it will shunt the DC voltage to ground. So back to isolation, you want to separate, get the wires off of the outdoor unit and see if your DC voltage comes back with no wires on it. So if it does, hey, that's great. The outdoor unit's good, and you're probably dealing with a grounded S3 wire.
But that's why then I think I would go. So correct me if I got this wrong, if I'm not thinking right, but if I take the wires off and I have the solid 24 volts in S2 and S3, I put the wires back on, I have 0 volts. I'm then going to go disconnect at the indoor unit. If I still have 0 volts, then I know the problem's in that wire between outdoor and indoor. But
there's a few different ways to do this. Yeah.
But if I take the wires off at the indoor unit and I measure S2 and S3, and I have the 24 volts, the solid 24 volts, then I know, hey, the problem's at the indoor unit.
Exactly. Yeah, you should always check at both places as you go through these different stages.
I'm sorry.
Out of all this, you guys nailed it on the head, right, Austin? It's all about isolation, right? Yep. Isolate. Because if you do not isolate, it will go, how I preach in my class, is you'll go down certain rabbit holes that we don't need to go down to. So,
exactly. There is a third possibility that isn't talked about a lot, but it does happen. And you can actually see this on the meter. But if you ever walk up to an outdoor unit and S2 and S3 is reading about 100 to 140 volts DC, that is always an indication that your polarity is wrong on S1 and S2.
So the first thing I'm doing, hopefully S1, S2, and S3 are not all the same color wire. Hopefully we're using 3 different color wires. I'm going to make sure that if I have black, white, and red S1, S2, S3 at the outdoor, I want to make sure I have black, white, and red at the indoor S1, S2, and S3. Now I have seen. I don't go out on many job sites anymore. When I first started, I did, but I actually saw S1, S2, and S3 at the outdoor unit. It was 14 gauge wire, and it was black, white, and red. And then I get to the indoor unit, and it's 16 gauge wire, and it's and it's green, white, and blue. And I go, where's the splice? And the guys go, there's no splice. I go, there has to be. The wire doesn't magically change color and size. So that's another important thing. That S1, S2, S3 from the outdoor unit to the indoor unit has to be a home run. No splices, no wire nuts, no butt connectors.
Yes.
The only thing we want to see there, if anything, is that the TAZ switch. Sometimes it's required by code. And here's a little secret. I think the way our manual is worded, there's a statement in there talking about the disconnect switch at the indoor unit, and it said, I believe it says something like should be required by local code. But the way that is supposed to read is should it be required by local code or if required by local code. The code, most states, the National Electric Code, as far as I can recall, and don't hold me to this, anybody, but I believe it says follow the manufacturer's instructions whether they require a switch at the indoor unit or not. We do not. But a lot of inspectors will see that and say, see, they're saying it should be required. And hopefully we'll fix that someday. I'd like to see that fixed. So that's just for out there. And just me personally, I'm not going to mention the town, but I had an inspector in a certain town who required us to put that switch in. Even when we had, and this is before I came to Mitsubishi, we had an engineer from Mitsubishi write a letter on Mitsubishi letterhead saying that's not required, and he required it anyway. But I happened to put a mini split in his house, and I was going to put the switch there. It was a wall unit, 1-to-1 wall unit, and I was going to put the switch in. He goes, I don't want that. So I can't mention the town, but. So,
I gotcha.
Anyway,
well, so speaking of the switch, you're right. A lot of people do put the switch in, and I think it depends on local code. If you're in a commercial building with an MMP product, sometimes they'll require it because it's a commercial application.
Right.
But that switch can get you in a lot of trouble too.
Yes, it can.
So, speaking of startups, if you were to ever, let's say you had the switch off at the indoor unit, the outdoor unit was powered down. And so you're already on the roof, you flip on the disconnect outside. If that outdoor unit doesn't immediately speak to that indoor unit, it's already in a communication error.
So that switch, if you do have a switch there, it has to be in the closed position before you power the outdoor unit on. And also, I've had service calls myself, Austin, where it's been running for a while, months and years, and then you get there, and it's not communicating, and you reset everything. You get there, the switch is in the closed position, the on position, but you get there, and then you start asking questions. Did anybody touch that switch there? And they go, oh yeah, my wife was over there wondering what that switch does. So if the unit is operating and you even momentarily open that switch, put it in the off position, you just lost communication. So now you have to close the switch and go back out and reset power. So I've actually, because of that experience, I actually had, I don't even know how many, many calls where I would avoid going out there by asking them, did anybody touch that switch? Is there a switch? Well, let me check. So, all right, go to the breaker, make sure the switch is on, go to the breaker, turn it off, wait 10 minutes, turn it back on. And if I don't hear from you, I'll assume it's fine. You know what? I'm going to say 50-50. I never heard back. So that switch can actually cause a nuisance call if the homeowner or somebody goes, hey, what does this switch do?
Yeah. Now, I will say when we're starting to get busy in the technical support side of things because it's getting hot across the country. So we're going to have a little bit longer wait times. And we get a ton of techs who have, spent an hour or two trying to get a hold of us just for us to tell them to, go outside, power. I mean, we'll be on the phone with them when they do it, but turn off the unit for 2 to 3 minutes. Generally, I would say no less than 3 minutes is what you really should do. If you don't have a watch, just make it 10 minutes. Like Paul said, make it 10 minutes to keep yourself safe. But
10 minutes is for the
3
homeowner.
minutes. Yeah, 10 minutes for the homeowner, but 3 minutes minimum. And when you power that unit back on, watch it probably start working. And you could tell right away. So if you walk up to an indoor unit and it says it has a communication error like an E6 error code, or on a M series unit, the indoor unit's constantly flashing a one-time flash. If you check across S2 and S3 and it's bouncing, it's communicating. It's just that at some point in time it lost communication.
Interrupted.
So it's going to require that power cycle. Yeah, it was interrupted.
And Austin, what else can interrupt that signal besides that disconnect switch at the indoor unit?
Okay, so this is something that everybody's familiar with, but condensate pumps are a big one. Now, if you look at most manufacturers we don't manufacture a condensate pump. All right, we're not in the condensate pump manufacturing business, but there are a ton of mini split condensate pumps out there, and a lot of their literature will tell you to break the S3 wire. I would recommend against that, and the reason is because yes, it will stop the unit in the event of a overflow for the safety. That's where you would tie in, break the S3 wire for the common and normally closed safety. But the problem is those contacts over time are going to start to get corroded and pitted. And because that's a communicating voltage, we would not recommend to break the S3 wire. We would recommend to break the S1 wire, the incoming power.
Right. So
both are going to do the same thing, but the other one's going to give you more periodic random comm faults that don't really exist.
Right. So if it's voltage, first of all, anytime a switch opens and closes, you have a chance of it getting pitted. But if it's voltage, it's not as severe as if it's communication, because now on S3, it's not voltage, it's ones and zeros. So a little bit of pitting can interfere with that signal. That's why we recommend S1. And it's important that switch be closed when you start up. Now, if you have not a fully clogged drain, but a slow drain, and that switch opens, and then it drains, and you'll get there, and the technician's going to get there, and there's no communication. So you're going to have to check that drain if that's a possibility, and make sure, because that could be a nuisance fault as well.
Yes, yeah, absolutely. The other one I've seen sometimes, not very often, but you were talking about the TAS switch earlier, which is just a 3-pole light switch essentially. But I have seen some technicians where they will put in a 3-pole disconnect switch with fuses in it at the indoor unit, because local code requires, and they just had it on their van. Don't do that, because those fuses will interrupt communication.
Right, no fuses. It should be, the TAZ switch, if, especially in a residential application, it's going to look like just a regular light switch. It goes on the wall. It looks like a single pole switch, but it's actually 3 poles behind it, S1, S2, and S3. And this is important too. If you're going to put a disconnect switch there, you have to break all three legs. You want to break S1, S2, S3. You don't want to put a 1-pole switch and break S1. You don't want to put a 2-pole switch and break S1 and S2. It's a 3-pole switch, the TAZ.
Or nothing.
Or nothing. Nothing is preferred unless it's required by code. And you're going to follow your local code. If it's required, what can you do? You have to do it. But make sure I'm sorry, Austin, let me just finish my thought here, because if I don't finish it, I'll forget it. But when you're installing this unit, the last thing you should do is talk to the end user and make sure they understand everything. Tell them about that switch and what it's for. Tell them not to touch that switch. Tell them if they do touch that switch, it can cause a fault, communication fault, and then they'll be calling. Explain to them what they should and shouldn't do with that. Because if they don't know, if you don't tell them and they don't know, how can you charge them? If it's just a few weeks after or a couple of months after you installed it, and you didn't explain that to them, you go out there and it turns out that somebody turned off that switch, then how can you really charge them? So make sure, if you explain it to them, if I come out here and you call me and it happens to be this switch, I have to charge you because it's not anything equipment related. It's not really under warranty. So just sit down for a few minutes and explain everything to them. Go over the remote controller. We talked about that in a past episode. Yeah, just do that. Yep. So I just wanted to finish that.
Well, you mentioned something just now that I think is really important for techs to realize. If in the event somebody were to use a 2-pole switch at the indoor unit, all right, and it's breaking S1 and S2. Yes, that will kill power to the indoor unit. But what a lot of techs don't realize is that we actually do have 115 volts to ground on S3.
Yeah.
So
115 volts on all 3 legs.
All 3 legs. Correct.
Yes, exactly. Yeah. So you're not safe just by using a 2-pole switch.
That's right. So it's important. So if there is a switch there, it has to be 3-pole unfused.
Yes, absolutely.
All right. What's the next topic, Austin?
I think refrigerant-related issues would be the next biggest one that we come across, and we can combine this with additional charge. But one of the biggest things that we're seeing lately is a lot of technicians are using the new smart multi-systems for residential applications with the branch box and the indoor units, and that's great. The problem is a lot of them don't realize you need additional charge for that unit. All right. So the unit comes with 10 pounds, 9 ounces for the 3 and 4 ton units. The 5 ton units, I think it's 11 pounds, 13
something
ounces,
like that. Yeah.
Something. Yeah. I don't have it memorized, but essentially that is not enough. That is just enough for the outdoor unit. Even if you only had 3 feet of pipe, you're still going to need at least a minimum of another 5.5 pounds just based off indoor capacity. So you got to pay attention to the install manual. And I think a lot of this gets confusing because on the outdoor nameplate, it will tell you that right above where it tells you what the charge is, it says, hey, charge is 10 pounds, 9 ounces. Right above that, it'll say the liquid line is good for up to 900 and something feet of liquid line. And that's not telling you that the charge is good for up to that much. It's just saying that you're allowed to have up to that much liquid line on the system.
Right. So you can actually take out the manual and follow that, and there's different formulas and mathematical things that you can do to figure out how much charge you have to add. Or I think we say this on almost every episode, use Diamond System Builder. Put that system in Diamond System Builder, have an as-built, how long is it, how high is it, all the lengths, put everything in there, and it tells you exactly how much additional charge you need to add, and you're done.
Yes, absolutely.
It takes the math out of it.
It takes the math out of it. You don't have to do math.
Much faster, much easier. But for the technician who is in a situation where they don't have a laptop, they don't have Diamond System Builder, on the install manual of those smart multi-units, page 11, if you were to look down at the bottom right of that page, it looks confusing, but really there's just 3 boxes you're looking at. There's a multiplier for the 1/4 inch. So for example, the 3 and 4 ton units, 1/4 inch multiplier is going to be 0.21 ounces
and that's a liquid
per
line.
foot.
Liquid line.
Yep, that's it. Yeah, just liquid lines.
Yep.
Yeah, we're not counting suction, so just liquid lines one way. The 3/8 liquid line, which on most as smart multi-units is just going to be from the outdoor to the branch box, because most of the time people are loading up with smaller indoor units. But the 3/8 liquid line is going to be 0.55 ounces per foot. And then to the right of that, there's a little chart that gives you it's based off of your indoor BTU capacity. So, for example, if you had anywhere from 27 to 54,000 BTUs of indoor connected capacity,
combined,
then that's an additional 88 ounces.
Yeah. And Austin, that part right there is, my opinion, is where people can our contractors get confused the most. Is reading that chart.
Yeah, it's the liquid lines. What diameter is the liquid line? How many feet of that diameter do you have? And there's a multiplier for that. That gives you the charge for the lines. Then you look at the total BTU capacity of all your indoor units added up, and you follow that chart, and it tells you how much to add. And that's I mean, it's that simple. It's not. I mean, it's not heavy math.
Yeah. No heavy math. No, but there is math to it. But what you have to be careful is, right? So when you go through all that, then you have to remember we have to add in what our factory charge is.
Correct.
Yes.
Right. With that equation. And you said on what, a 3 and 4?
3 and 4, it's 10 pounds, 9 ounces.
So you got to convert that 10 pounds into ounces.
Yes.
Yeah.
Right?
Which some of the manuals will say it's like 180 ounces. I think is
so
what it is. Something like that.
Okay. Oh, that's
Yeah.
And then,
now, if you're doing a brand new startup, then that factory charge is already there, so you're just doing the additional. So
right.
Yep.
Yeah, that's if you come in on a service call later, you need to know how much was in there.
Yeah,
but the important
exactly.
thing is to somewhere on that unit, and I like to write it with an indelible marker, like a paint marker, inside the panel. I like to write the total charge of how much I added. Not outside, even though it's recommended you put it outside, but outside the sun hits it, the weather hits it, it fades away. If you write it inside where the sun's not going to hit it, the weather's not going to hit it, it's always there. How much total refrigerant is in that system? Because you may be the one coming back several years down the road where a dog's been chewing the liquid line and all the refrigerant left, and you need to know how much refrigerant you need to put in. That's actually a service call I had. A dog kept chewing the refrigerant lines, both of them. But anyway, now you know how much to put in there. But getting back to the Diamond System Builder, the DSB, the one thing, even the charge is a good thing, but it's also going to tell you if you exceed a maximum length. So that's it's a safety thing. So if you put that system into a Diamond System Builder before you run the piping and you think this is where it's going to go, you put in how many feet you think you're going to need of pipe, and it'll tell you, can't do it. If your maximum height difference, if your indoor unit is too high or too low from the outdoor unit, the maximum separation is exceeded, it's going to tell you. So please use Diamond System Builder. Those of you who are designing this, are going to sell this, build it in a DSB so you know if it's going to work or not, or if you're exceeding anything.
Absolutely. Yeah,
So
and we get a lot of
those on the call don't know. Go to mylinkdrive.com. Select the USA, and then go to the software tab, and that's where you'll see Diamond System Builder and get your software from there.
Yeah, and it costs $1,000 to download it and get a license for it.
Really?
No, just kidding. Just kidding.
You want to give out your Cash App?
Yeah. Actually, send the cash directly to me. No, listen, I'm just kidding. It's no cost whatsoever. So download it and use it. You can create an account in there if you want, put your email in there, and updates will be sent to you, messages and so on if there's a thing. And it's updated. I think it's updated like once a month with different equipment and stuff.
I think more than that.
Yeah. More than that, but yes.
Yeah, they're constantly updating it. All sorts of stuff. So one of the other things that we get a lot of calls on are...
Austin, before we move on, I just want to mention one thing about the refrigerant. If you come across a unit that's been installed for a while and you suspect that there's a leak, then that means it wasn't installed properly, in my opinion. Because
I would say that's true.
if you install a system properly, you're not going to have a leak. If you use the proper flaring tools, if you use torque wrenches, if you do a triple evac and you pressurize the system before then you know the system. Because I've mentioned this before, and I hate to keep talking about it, but you will know if you follow the proper procedures that we talk about in class, you will know without a doubt when you leave that job that there will never be a leak in that system because of your workmanship, and you know there's no moisture in that system. So I just wanted to kind of, re-nail that home again. All right.
Now, I will say whenever it comes to leaks, if you're finding leaks in evaporator coils or anything like that, pay attention to the air quality. I'll be honest. We get a ton of calls where, the techs are like, hey, this is my second or third coil. And when we start to ask them about the application, it's a newer home. It's spray foamed. It's very tight, but there is no fresh air.
Yeah.
If you don't have fresh air, it's going to start to cause formicary corrosion on the coils, and it's going to eat them.
Yeah,
it really will.
Yes, it will.
And that's actually, the fresh air is actually a requirement. You can't, you're supposed to have fresh air, especially in these tight homes. You need that fresh air coming in. And by the way, good use of the word formicary.
Right?
Very nice. Yeah.
Impressive. All right, Austin, let's talk about airflow. Do we have any airflow calls?
We do get quite a bit of airflow calls, and a lot of this has to do with retrofits. So a homeowner had a unitary system in their house, and maybe they had an air handler, maybe they had a furnace, whatever, but the technicians are direct swapping it out for a Mitsubishi, but they never did anything with the ductwork. And Scott is probably the most expert I've ever seen on airflow. If you were to call the TSAs, we don't do airflow. We will troubleshoot the system 100%. We'll try to help you. But when it comes to proper airflow, I can tell you what the static pressure availability is for each unit. And we can set it to whatever you want, but if you don't know what that static pressure is or what it's doing, it could cause a lot of problems. Performance issues, typically.
Performance issues is really the key there, Austin.
I think as an industry, for the most part, especially on the residential side, that I don't want to say most technicians, but I think a lot of techs, a lot of sales guys that go on a call that are going to replace any type of air handler with existing ductwork, I think it's something that generally speaking, as an industry, that we miss. We don't look at. We think, hey, we're taking out a 100,000 BTU furnace, a 3-ton air conditioner or whatever. We're putting the same thing in. That we don't really think about that. But I know up here in the Northeast, when I started in the trade, I'm not going to say when, but there were a lot of homes. I mean, air conditioning wasn't common. You have a gas furnace, you have your ductwork in there, but a lot of time the ductwork wasn't designed for air conditioning. It wasn't even designed for heating. A lot of times I think they just slapped it in. I mean, you got, there's a whole neighborhood, in actually a couple of towns. There's several neighborhoods in some towns I used to work in where they got the plenum off of a furnace and they got 4-inch hard pipe going to every room. And then they squeeze the 4-inch to fit inside a 2x4 wall. They kind of squeeze it to go in there. And what are you going to do with that? There's not a whole lot that you can do. So airflow is a big one. And I know, Scott, I'm going to put you on the spot here. I'm going to put you on the spot
real
here.
Quick. That's fine. But real quick, regarding airflow, though, our listeners, we have a great podcast on static pressure regarding airflow on that. So please take a listen to that podcast.
Well, I was going to ask you if you know off the top of your head the formula to measure airflow.
Well, yeah. What formula do you need?
There's a
length times width divided by 144 times feet per minute is your CFM.
Yes. But go listen to the podcast because I don't understand anything he just said.
I don't either. Let's fix the compressor, diagnose something else. I'll leave the airflow up to Scott.
All right, Austin. What else we got in line for us?
Application issues. So application issues tend to be a pretty big one. One of those application issues I want to talk about is bonus rooms or conference rooms that aren't going to get used a whole lot. And the reason I want to mention this is because, especially for you guys up in the Northeast, all of our one-to-one systems from the factory come with no crankcase heat. All right. So in the event that this is a bonus room or a something that's only used once a week or whatever, and it gets cold outside, so the system's not being ran, there's no crankcase heat on that compressor. So we get a lot of misdiagnosed compressors because of this. Now, if you were to look in the service manual, there is a jumper you can cut on these 1-to-1 systems. And when I say 1-to-1, I'm just talking about the M series units.
True. Yeah.
Yeah. But there's a jumper you can cut called the JK jumper, and it tells you to cut it if you need crankcase heat. Essentially what it does is when the outdoor ambient temperature is less than 68 degrees, it'll trickle charge the windings of the compressor to keep the compressor at least 20 degrees above ambient. So, knowing what the system can do, what it should do. I wish that part was in the install manual, but it's not. It is in the service manual. And if you're curious where the JK jumper is in the service manual, there's always a test point diagram you can look at, and it'll actually point right there to it. It says, here's the JK jumper. All you got to do is snip it in half and give it a power cycle. Right. I'd probably prefer you do snip it with the power off anyway.
Yes. Oh, yes. Yeah. No, yeah. Exactly. But because this is important, because I used to have a lot of customers with vacation homes. So vacation homes, late fall, early spring, even in the winter, they're not going to be used a lot. They're going to turn down the heat or turn it off. So when they go out there, so you take that jumper and you have to cut it, because if you, in a typical system, if it's going to run in the winter, it's going to run long enough where it's not going to need that crankcase heater. So it doesn't hurt to cut that jumper anyway if you're in a cold climate. And when we manufacture these, we don't know where in the world it's going to go. We don't know if it's going to go, in Maine or Michigan, or if it's going to go in Florida or Aruba. Yep. Right. So that's why, for those of us, why can't it just come that way? That's why it can't just come that way. But if you're going to be in a cold climate, take that JK jumper. It's just a pair of diagonal cutters, and just cut that. It looks like a little resistor. Just cut one end of it, and we'll take the whole thing out, and you're done. And that's it.
And you'll thank yourself later.
Yeah, and now when the system's not running and the temperature's below a certain temperature outside, it's just going to trickle through the windings, one winding at a time, and heat it up. And when it's heated up, you're not going to get the liquid in the compressor, because we talked about this last week. Liquid in the compressor, if it's sitting there, it's not going to start.
Nope, exactly. So, it's just one of those things to be mindful of. What's the system going to be used for? If it's going to be a primary heat source, I'd still recommend to cut the jumper if you're in a colder climate, but it's probably not going to ever give you issues because the system's constantly, running.
Operating.
Now, I do want to say one thing. If you're sitting there in your truck right now and you're listening to us and you say, hey, I've installed a bunch of these and I never cut the JK jumper. If you don't have an issue and you've never gotten a call, you don't have to rush out and cut all the JK jumpers, right? But going forward, it takes you 3 seconds to do. Go ahead and please do it.
Yeah. So if you're ever in the situation where you're trying to diagnose a compressor, which we'll talk about in a little bit, and you're just like, okay, well, I've narrowed it down to the compressor. It never hurts to just cut the jumper, turn the power back on, tell the homeowner not to try to start the system. Go order your compressor, because you can always cancel the order, and then tell the homeowner that, after 12 hours to try to turn it back on. If it comes back on, hey, the crankcase heater did its job, and that compressor was just had some liquid in it and wouldn't start.
It's something that just occurred to me is a power failure. I once lost power for 5 days during a snowstorm. It does. And if you don't have a generator and that thing is sitting there, whether it's got a crankcase heater or not, you can't just go start it back up. You're going to have to wait for that to charge. And if you don't, that JK jumper's not cut, it's not. So keep that in mind. So it's a good idea in cold climates or medium climates. If it's going to get in the 30s and 40s or lower at any point in the year, go ahead and cut that jumper. It doesn't hurt a thing.
Exactly. The other application issue I wanted to talk about was putting M series units in high heat load scenarios year round. So like server rooms, elevator rooms, audio video rooms, whatever the application may be, whether it's commercial or residential.
So critical cooling, where you're going to need air conditioning no matter what it's doing outside.
Yes, we have a product for that. It's called the P Series product, which is professional grade.
Yeah, M Series is not recommended because of the way it operates. So run us through that. So let's take it. Yeah. I'm in cooling, and it's going to get in the 60s or 50s outside. If I have an M Series versus a P Series, run through and tell us the difference in how they work.
All right, so this is where it gets pretty interesting. So let's say we had a MUI cooling only system, and it's 24,000 BTU, so it's a 2-ton system. All right, and you have a server room that's got a constant 2-ton load needing to be absorbed and rejected outside. What's going to happen is the outdoor fan is only controlled by ambient temperature. So once the ambient temperature gets to 64 degrees or less, the outdoor fan goes from a high speed to a low speed. Now, during that high speed and low speed, you might see it modulate up and down a little bit. But if it goes to a low speed and you're trying to absorb 2 tons of heat out of a space and reject it outside, now what's going to happen is just going to have a hard time rejecting it with that fan in a lower speed. So you're going to get a higher head pressure, a higher suction pressure. Your delta T inside is going to go from a good 24 degrees down to about 10 degrees, and you're not going to cool that space.
All right. So that's important to know. And it's a proper application. If you have critical cooling, you need it year-round, a P-Series is the way to go. Don't try the NEM series. Austin, what do you think about this? I've actually seen a lot of people for that when they need critical cooling, they put an M-Series unit, the outdoor unit, inside. So I've seen in applications where they have a warehouse and they'll put the unit inside, they'll hang it on a wall or up in a ceiling in an office, and what do you have to worry about then?
Yeah. Well, obviously, if you do have to worry about the cleanliness of the unit, because if you've ever been in the warehouse, those things can get pretty nasty with the forklifts, dust from the tires and all that stuff. But sometimes that's the only option you could do. We have a ton of calls where this was installed, last summer. It worked great, but now it's shoulder season and it's not keeping the room cool because it's an M series in a server room type of application. So relocating the condenser is about your only option to get that system working other than putting a P-Series in. So if you can't go with a P-Series, relocating it inside above a ceiling grid in a warehouse, something like that, as long as that space temperature is above 64, you should be good.
And as long as there's airflow there, you don't want to just put it in the ceiling and close it, because now you're rejecting all that heat into that space. So you got to know about, because now you're adding extra load in there. So you need to make sure.
Yeah.
And like in the warehouse, there was a warehouse that was actually a machine shop that I saw one in. And it got dirty with all the oils in the machine shop and everything else. But these guys in the machine shop would get hot. So in the winter, they'd open the big bay doors and it would just get nice and cool in there. And, so that can affect it too. So all the things you need to think it through and not just say, okay, this will work.
Yeah. The craziest call I ever had was from the EPA. So somewhere in North Carolina, there was this mountain. And on the side of the mountain, they had this what I would call a very small trailer. I mean, maybe like 10 by 10. And it was an air quality trailer that essentially they had 3 of them on each side of the mountain. I think they had one on the north, one on the east, one on the west. They didn't have one on the south for some reason. But his one on I forget what side of the mountain it was on, but one of them, it would not keep the space temperature at nighttime. And they had all this monitoring log data that he sent me. And it was pretty amazing. You could watch when the outdoor temperature hit 64 degrees, you can watch the indoor space temperature start to rise. It would get up into the 80s to the 90s. And then
that's cool.
As soon as the sun came out and that outdoor temperature got above 64 degrees, that space temperature started going back to set point. And when I explained to him how it worked, he was like, oh, crap. And the reason the other 2 worked, believe it or not, was because they were on the side of the mountain that had the most wind. So at night, that wind was rushing across the coil, helping to get that heat off the coil since the fan was in a low speed.
Interesting.
Okay.
So had they used P-Series, they wouldn't have had an issue. And
they wouldn't have had an issue.
And they're also popular in cell towers. So you got the cell towers, you got the little building in there, so they're popular there.
That's a big thing. Yes, exactly. Yep.
Yeah.
All right, Austin. So last week or the week before or both, we talked about compressor diagnostics. So I think it's going to be the same thing for M and P series compressors. They diagnosed all the same way. So anything you need to add that we didn't talk about in the last 2 weeks?
The only difference on M and P stuff is there's no dip switch, basically. But essentially, all you're doing is if you got a unit where the fan comes on, and then 10 seconds later, the compressor tries to start and it shuts down and it's giving you some type of compressor overamp error code. Isolate the compressor. So power down, take the wires off the compressor, start it up again. And then we're looking for the same thing we talked about in the City Multi side on the podcast last week, where you're just looking for a balanced AC voltage. So when the system comes back on, how does it act? Does it act differently? Does the fan stay running this time? And if it does, are we getting a balanced AC voltage out of the wires coming from the inverter board? Yeah. And so it's pretty much the same troubleshooting.
Yeah. The only thing I have to add, just for M&P, right, for the outdoor power, 208 single phase. So and then we go with our inverter, then that's when we go into a 3-phase, a UV and W to our compressor. Right. So I just like to add
it is 3-phase. Yeah. So just make sure it's black to white, black to red, red to white. Yep. You get a balanced AC voltage. Doesn't matter about the voltage as long as it's within 5 volts of each other.
That's right. And if you use the inverter checker tool that we have, there's actually a plug on the tool that you take off the alligator clips, and there's actual plug on some of the units that goes to the compressor. You unplug that, you plug it into the tool, and you're there. You don't have to worry about the wires touching each other or anything else. So the inverter checker tool is good to have. All right, and I also talked about the last couple of weeks thermistors. Anything different with thermistors on the M&P series that we didn't talk about in the last 2 weeks?
There are. They use different value thermistors, where City Multi is pretty much the same value across the board on all the residential and light commercial products for the M&P stuff. You really need to look at the test point diagram in the service manual to figure out what the values need to be. So there's no one universal thermistor.
And they're not interchangeable. I can't take the TH4 and replace it with the TH7.
No.
Okay, and about addressing. So a lot of people think there's addressing is just City Multi, and mostly true. But when on an M&P series do we address?
Okay, so anytime you're going to have a branch box style unit, so this would most likely be the smart multis going forward, but you probably do want to address. Now, if you don't touch anything and start it up, it'll start up just fine. But the reason I say you probably want to address is because if you are using anything that plugs into CN105, if the system is an address, sometimes you get weird, funky stuff happen. And I won't go into all the weird, funky stuff. It's nothing that's detrimental or anything. It's just weird things could happen. So addressing on a smart multi is pretty simple. If you're familiar with addressing, then the outer units are always going to be 51 to 100. Now on the indoor units, you can't actually address them. So what you're doing is you're setting the address of the branch box for the lowest port. So on the branch boxes, there's an SW11, which is your ones place, and SW12, which is your tens place. Most applications, it's just going to be 0-1, right? Because they're not going to have a lot of units and stuff. So
with a smart multi-branch box system, you're addressing the branch box, and then the indoor units will be addressed based on that. There's nothing to do at the indoor units.
There's nothing to do at the indoor units, but there is a SW1 dip switch bank. You do need to tell it which ports you're using on the branch box. And that's pretty important because, if you don't do that, you're going to get some error code. So if you touch anything on addressing, do all three. Address the outer unit, address the branch box, and do the dip switches. Tell it which ports you're doing.
The only thing I have to add for addressing, especially at the branch box, is I look at the dial. Make sure you look at, there is going to say a 10 and a 1. This is why I tell my contractor, 1 is the 10 digit, right? 10, 20, 30, 40, and then the 1 digit 1, 2, 3, 4. So make sure the 10 is 0, and then the 1 digit 1. And if it's hung on the ceiling, this is the biggest caveat, right? If it's hung up in the ceiling, that board is upside down.
Yes.
So you have to be very, very careful when they're addressing, because addressing the outdoor, it's just whatever you address the branch box, it's plus 50 for the outdoor unit.
Don't address it left to right. Don't address it left to right because the thing's upside down. Look at right below the switch or above the switch, depending on how the box is installed. Look for the 1s and look for the 10s.
And
ones
the 10,
positions,
that's
10s
all
positions.
I do. Exactly. One thing. Go ahead.
Go ahead.
No, I said what I tell people in my class, that if you want to bypass that, address it 11. Because it doesn't matter which way you address it. It always forever be 11, and then plus 50, 61, you move on, and then you're good to go.
You can't screw it up that way. I just want to say one more thing about addressing, too. And you mentioned, Austin, if you can start it up and not address anything, I don't really recommend that because somebody can come along later and do something. I recommend address it properly. Now, did you have something else to add, Austin? Because I think we talked over each other.
Well, yeah, I just wanted to mention about the outdoor unit. That is the only one that gets confusing. So that is where you want to go left and right. And the reason that is on the outdoor unit rotary dials, you got SWU1, which is your ones place, SWU2, which is your tens place. But underneath it, instead of saying ones and tens, it says first digit, second digit. So a lot of guys end up addressing it 15 when it needs to be 51. So just go left to right at the outdoor.
So first digit is ones, second digit is tens. That's how I remember. Look for the one.
Yeah.
First or one is the ones position. Second digit or tens is the tens position. And if we're installing a smart multi without a branch box, you address it the same way you do any city multi system. Nothing changes because now you're using city multi heads.
Yeah.
Right?
Yeah. The only difference is if you are using a branch box, make sure to turn on SW2 number 5 at the outdoor unit. That's important for the branch box.
Yeah. And then let's switch gears and go to electrical. There's one electrical problem that I know is quite common, and we actually have a recording of somebody who called in for this years ago. Sometimes the guys will play in class. But what's the voltage of an outdoor unit? What's the power supply needed for an outdoor unit, an M&P series?
Everything except for one model is going to be 208, 230.
208, 230. If I make a mistake and I just run 120 volts to it, what's going to happen?
That thing is going to work beautifully all summer long.
Yeah.
So everything in the system is inverter driven. Like literally everything in the system is inverter driven except for two things. The reversing valve coil, it needs 208, 230 to shift. And the indoor condensate pumps, a lot of them still have the old 208, 230 pumps on them. So those need 208, 230 in order to operate properly.
Right. So if I run 120 volts to the outdoor unit and I run S1, S2, and S3, and I do this in the summertime, let's put aside the condensate pump thing for right now. But let's just say I got a gravity drain, a wall unit 1-to-1. My air conditioning is going to work just fine. But when I go to turn on the heat, I'm going to get a phone call, the technician, and I'm going to go out there. And this happens more than you think. Right? And
it does.
So
it does.
Look at the nameplate, make sure you got the proper voltage going to it, proper power supply going.
So every fall, as a TSA, one of the joys of taking calls is getting this call, because it's like you can see the light bulb go off in the technician's head, because it's not, you're like, hey, it's operating, so why would I even look and see what it is? It's working fine. It's got to have the right voltage. So the technician calls in and he's like, hey, this thing just isn't going into heat. It's constantly cooling. And then you're like, okay, well, let's check S1 to S2, and he's got 120 volts. All right, what about L1 and L2? He's got 120 volts. All right, okay, look at the nameplate right there. And then he's like, oh, crap, I figured it out. I'll call you later.
Yeah, nameplate tells you everything.
Yep. So that's a fun one.
Now, Austin, what's for the next thing we're going to talk about? This is coming up more frequently. Correct, with our P series indoor units with was SW5-8.
Yes, so SW5-8. So some of the new P series indoor units, specifically the wall mount units or the PLA four-way cassettes. Yeah. Those are going to have a dip switch that you have to turn to the off position in the event you are using a PAC YT53 simple MA, or there's still a old PAR 21 on the wall there. So generally, and the reason for this has to do with the newer controllers having the ability to function at higher speeds and actually look at data from the outdoor unit and things like that. So the factory is basically saying, hey, if you got a nicer MA controller like a PAR 40 or whatever's coming up after that, then the dip switch is fine to keep in the on position. But if you have something that's like the simple MA or an older controller, you got to turn it off.
So let's backtrack. Okay, so the customer they install a simple MA controller. On their end, what are they going to see?
On their end, what's going to happen is on the simple MA, it's just going to say HO on the controller the entire time, which literally just means hold on.
Okay. Yep. So from that point, that's where they have like a four-way cassette, 8th generation, by the way, correct?
Yeah, 8th generation.
Heads.
Correct.
Yep. So in that case, they're going to have to go into the indoor board and hit that dip switch 5-8, so it can communicate with the indoor board. Okay. All right. Yes. I just wanted to. All right.
Yeah.
All right.
Yeah.
Austin, let's give you the last word. Is there anything else we need to talk about or you feel as though it's important for our listeners to know?
I would say don't be afraid or too prideful to call technical support. You might be the best tech in the world out there, but you guys work on hundreds of different products, year in, year out. Us here at on the technical support side of things, we were all in the field, so we know what you're going through. So if you tell us you have to go inside and that requires walking across a roof, you could land an airplane on, going down a ladder, going through security, we get it, right? We're not gonna dog you for it or anything like that. But now we're in technical support, and we do this day in and day out for Mitsubishi. So don't be afraid to call us. We're not going to look down on you for calling us. Sometimes you need an extra hand.
Austin, I just want to thank you very much for joining us for 3 weeks in a row. You bring a lot of experience, a lot of knowledge that comes with you. I think we're going to make a regular thing. Maybe once a quarter we come on, you update us on new calls that you got, the odd ones, the interesting ones. I think we'll do that however often, but we'd like to have you back again. Thank you so much. And we'll be sending you a gift in the mail.
Even our
just look for it.
Yeah, come on. Oh, okay, Paul.
Hey,
we'll take them out the noodles.
I want corn dogs.
No,
we'll take them out the noodles.
Next time I come to Swanee, we'll take you the noodles.
I'll do the noodles.
All right.
Yeah,
we love noodles.
Have you been there? Have you been to Noodles?
Umaito, yes. Yeah, I love Umaito.
Yeah, you can't work there and not go to Noodles.
Right. So I did my class yesterday, Paul, and finishing up. And the day before, some contractors asked me, "Hey, Scott, where do I need to eat?" And I always recommend Umaitos. And I get there in the morning. A gentleman came up and shook my hand in the morning and said, "Thank you."
Yeah.
Just thank you. That was just delicious.
During my interview process 12 and a half years ago here, one of the guys asked me, he goes, "Well, as part of a requirement for working at Mitsubishi, can you use chopsticks?" And I lied and said yes. And then I went home and had my wife teach me how to use chopsticks.
Yeah.
So my interview process was making sure I can eat the spice level at Amato's. All right.
And making sure you don't check your bags at the airport. Okay.
Oh, dude, we really gonna keep bringing that up there, Paul?
No, we gotta go. All right, guys, we'll talk to you later. Thanks.
All right, thanks.